This is a demonstration of SaltStack orchestration for Docker containers. Really, in truth, it's not talking about Docker too much, but what better way to get good VC funding than putting Docker in a title of a slide deck, right? Or a talk? There you go. So, all right, there's all my jokes, and that wasn't even any good. So really, it's more tailored towards a demonstration of SaltStack orchestration for Docker containers to act like a serverless infrastructure or function as a service, if you will.
But that was way too long.
Right. This was much, much too long, although it was the one I really wanted, but they said no, so this is what we get. But let me move this over here. So my name's Charles Ruffino. Oh my goodness, that's a big face. I've worked at a couple of companies over the course of my career, SaltStack being where I am right now. There was one on here that I just couldn't find the logo for because they've been gone for too long, and the Internet Archive didn't have them any longer. So there's a couple of those that I had to pull from there. But anyway, I'm a solutions consultant or technical solutions consultant for SaltStack, which is basically translated into a pre-sales engineer. I make sure that my sales guy is telling the truth, which thankfully Salt is a very wildly usable product and capable of doing just about anything. So based on your imagination, you can pretty much do whatever you need to. So what is a microservice? Something that's very tiny, right? This little bitty thing. When I first started doing some searches for all of this talk, I found this. Writing Docker microservices in COBOL, and I thought, you know what? I didn't know COBOL was still being used, but it is. Apparently it's like the 24th most popular language still. And you can apparently create microservices in COBOL. I did not know this. But this guy, Greg Coleman, if you just do a Google search for writing Docker microservices in COBOL, you'll find his webpage and be amazed, because I was absolutely amazed that he was even doing this. But really effectively, Gartner considers microservices as being a tightly scoped, strongly encapsulated, loosely coupled, independently deployable, and independently scalable application component. That's a long... Yeah, that's why I didn't memorize it. So, based on a combination of SOA, God, my brain just died. Service-oriented architecture, thank you, yes, and a domain-driven design. Basically, microservices architecture is a design paradigm. That's the most important piece here. It's really it's a way to do things. It's not a new cool thing. But it basically has these three core objectives: development, agility, deployment, flexibility, and precise scalability. Martin Fowler, if you guys are not familiar with him, he kind of writes about microservices a lot. And he says, in short, it's an architectural style, which is exactly what the Gartner thing said as well in much more flamboyant words. But effectively, it looks like this. You have an application monolith. When you're building your application, it looks the same on every single system that you're putting it on. And it's all of the stack put together. Whereas a microservice, you're basically breaking each of the components apart and utilizing them in ways that they need to be utilized. And this gives you the ability to do a few different things within your architecture of what you're doing. This is another view of it. Monolithic architecture, basically you have your UI, your business logic in the middle, the data access layer, and the database, right? And then when you move into a microservices architecture, this is really basically splitting those components apart, as I said, and then having each one able to be called to do its task as it's needed. And as I was doing my search again, I found a really good graphic to define this, not this one, but this one. So essentially, if you have a big pile of crap and you spread it across little bitty small pieces of things, it's now a lot of small pieces of crap. I did not make this up. Alvaro Sanchez at Adobo did. But when I saw it, I said, I have to have this for my talk. I'll wait just a moment. Any other pictures on this one? By the way, these slides are available in the app. You can download them after this session or right now if you want to. But continuing down this path, microservices architecture, again, loosely coupled service-oriented architecture with bounded context, basically does as few things as necessary in as limited amount of an area as possible. in order to isolate all of the functions of the things that you're doing and have things communicate in an asynchronous manner. Basically making each one as independent and simple as possible. But then really when you're talking about microservices, it's kind of moving into the realm of a serverless type of notion, right? So serverless architecture, leveraging third-party services such as Lambda or Azure Code or any of those other big guys that are asking you to send them some money to be able to do these tasks. Basically gives you the ability to eliminate the need to establish and maintain that traditional infrastructure, right? But really you're just splitting those pieces apart. So the elements of a microservice, or really characteristics, if you will, each functional element is a separate service. All elements are deployed independently, and all elements are deployed across servers as replicated as needed. They just, whatever you need to do to be able to manage the load of the thing that you're doing is what it typically looks like. So elements of serverless, and I added this in here because kind of the way that these work together and it moves into what I want to demonstrate anyway, which really didn't have that much to do with Docker except for one little spot that I'm going to show you in just a second. But effectively, serverless is operational responsibility being abstracted away to a third party. So you're putting your stuff on someone else's hardware and trusting them to manage and maintain that infrastructure for you. Code runs within a series of entry and exit hooks. Other services are exposed as integration components or endpoints, if you will. And the services are connected together, not necessarily through an API, but through these events that are happening. And this really lends itself to what Salt does from an event-driven orchestration standpoint to be able to do this type of behavior very easily. And of course, the model could grow from its existing ecosystem, and it allows for a very flexible approach for developers. So they don't have to worry about the back-end things of what's going on in order for them to get their code out. So author C Clarke wrote years ago, these are his 3 laws, if you will. The first one doesn't really apply too much to what I'm talking about. So when a distinguished but elderly scientist states that something is possible, he is almost certainly right. When he states that something is impossible, he's probably wrong. This is true, yes, but the only way of discovering the limits of the possible is to venture a little way past them into the impossible. But the most important part here is any sufficiently advanced technology is indistinguishable from magic. And that's really what you get with technology that we're about to show here. It's kind of like magic. So, elements of Salt. You guys have been here for a little while. Today, have you enjoyed yourself so far? Yes, yes, excellent. Salt is a high-speed, secure communications bus that can send targeted publications to all of its connected hosts, and then have those hosts act on those publications. And then, of course, it's a configuration management engine to provide idempotent application of machine states to those hosts, and it has a reactive backplane to be able to respond to different events that are happening within the infrastructure. It also provides a programmable interface to allow for those reactions to be specified for different events and triggers. And if you guys have never seen this before, it's just basically an overview slide of all of the different features of Salt, which is really not all of the different features, it's just a couple of them, because there's a whole bunch of stuff that Salt does. But effectively, I'm going to be talking about the Reactor today, and I've created an engine as well that we'll be going through. So the Reactor side is essentially when a command is run or published down to the minions, essentially, a command or it goes to the minions themselves, and the minions then respond with those events and go back into the message onto the event bus. Let me get some water here. So then a Reactor basically looks at an event and responds to that event in some way, shape, or form, doing some sort of task, whatever it may be. So say, for example, you have a brand new minion coming on. It's just starting for the first time, and you want to do an action every single time that minion starts. You can look for that minion's start event on the event bus, and then utilize a Reactor to respond to that event to do something else, whatever it may be. Now, an engine is essentially an extremely long-running, extended system process that leverages Salt. And we have a couple of engines that we've built to allow you to be able to view different things within the infrastructure. So we have like a Slack engine and Logstash, Napalm, And there was a couple other ones in there. HipChat, yeah. So, but Docker events, since we're talking about Docker a little bit today, I'll show you the Docker engine in just a moment here. But effectively, this gives you, an engine really gives you the ability to check for an action or an event on an external service or an external system, or a third-party system, if you will, and then still use Salt to react to that specific instance. So, demo time. All right. Nope, no conclusions yet. I haven't shown you anything. All right. Couple of things first. I had to set some things up in order to get everything to work, and I'm going to kind of run through all of that right here. And I'm going to make it a little bit bigger because this is silly. All right. And since it is... So in the master configuration, I added just a couple of config settings to be able to ensure that what I'm doing for this presentation, or this demonstration, works appropriately. So I just specified the engines directory. I didn't really need to explicitly state the file roots location, but because this is the default, but I did it anyway. And then runner dirs and pillar roots. So then this is on the master side from a master config. I created these two engines that just simply do a validation of the configuration that I have installed. And then it's a simple HTTP page using Tornado to make those reactions and responses. On the minion side, created a quick beacon and specified which master this is that it's connecting to. And the beacon really is nothing more than an iNotify beacon that looks for the creation of a specific text file in var fas, and then it looks at the close write instance to then be able to basically send that notification out to the event bus so that we can see it. The engine, here's that config builder. Very simple, nothing special to it, really just looking at the location for where my pillar data is, and then it's looking for any manifest files in that location of /code on my server here. And it just validates the pillar details, ensures that the information that's being utilized for the specific pillar information is valid in order to be able to run the right command for the right specific system. And then simple HTTP, this is really, really simple. I basically just create a response to whatever it is that I'm trying to do. So, and I'm using Salt details to be able to publish this content or this information back to the event bus, as well as utilize the whole function for what we're doing. As you can see, I'm utilizing a runner here for Lambda events, and I'll show you this Lambda events piece in just a second. I have my file here, but it effectively is basically looking for the one instance of my HTTP keyword ingress. So before I get to that, though, I have a pillar detail here. It's just simply specifying what could be considered a manifest. In serverless notations, they typically talk about utilizing serverless and even microservices. A practice of utilizing them is typically to have a manifest file of sorts, or a manifest that states what the system is supposed to do. And in this case, we really don't need it because of the way that Salt works. This is just simply feeding back pillar data to the system in order for us to be able to run what we're trying to run. And I wrote it in JSON because JSON is quite fast to compile through the renderer for Salt. And you can talk to the really smart guys in the back to understand that more as to why. Or we can talk about it later. Entirely up to you guys. But effectively, my Lambda events, this is really the bulk of the thing. It's a very small bit of code here, but I'm looking for any system that has a grain of Lambda being true. And so I just set a grain on a specific node, and then I'm using that node as my Docker host, basically, so that I know which host that I'm connecting to, meaning that I can have multiple different systems to be able to utilize this type of behavior. And then, of course, looking at pulling the pillar detail as well. And then this is that HTTP keyword ingress. And really, this is the whole piece of where we're doing things with Docker here. So effectively, I get the Lambda host itself, and then specify that this is a command.run from Salt, So Salt utilizes we utilize the module of command and the function of run within Salt to be able to activate this specific instance. And then I call the Docker run instance and specifying the volume that I'm mapping, and then the specific container that I'm pulling down. This is a public container. You guys or a public image. You guys are able to pull it down anytime that you need to and play around with it as needed. All it is a Ubuntu 14.04 box with Python installed. Nothing more. So I specify the language that I'm using, so in this case Python, the function that I'm going to run, whatever the function is, which will be built or compiled from the web page that I'm clicking on, and then the specific keyword that's being utilized. So what I'm doing here is, since engineers really enjoy doing things that distract them wildly, this is a solution that allows you to, for this demonstration, it's a solution that allows you to call GIFs from Giphy.com, because everyone needs more GIFs, right? So if you guys came to this talk last year, we did it a little bit differently, but we had a web page that was a little bit more robust, and it was almost kind of like coma-inducing because of the flashing that was happening. But anyway, so I pared it down substantially now, and effectively just being able to utilize this in a very easy manner. So this is really the bulk of the solution here, or this specific microservice, if you will. I had to install a couple of components in order to get this working on this minion. So I installed Docker, because you have to have Docker, right? We have a pretty robust formula for Docker. If you go to Salt Formulas, you can find this sitting there. And next, I needed to install some specific code and some my Lambda code, which basically just says, take the Docker details, and I want you to install Nginx as well as Docker, and then I want you to pull down this particular, thank you, this particular image, which is SaltMe Lambda v2, and then I'm specifying that I want to recurse the code, or recurse the files that are sitting in the Lambda location, Lambda code location, which is basically these two files, giphyget and the manifest.yaml, which you can't really see very well over there, so I'll show those in just a second here. But Nginx, this is nothing more than just installing it, very simple. Make sure the service is running as well, and we specify a requirement to make sure the package is installed before the service is running. Simple salt, or basic salt details there. And then, of course, we have to use pip for the Docker install, because that was a lot of fun, and we upgrade pip through once it's installed, and that's really where, when you're looking at the initial Docker installation, it says include pip. And so that's based on there. And then the giphy-get py file, this is really the meat of the piece here. And all I'm doing is I've specified my API key and my host ID, and then I have it's just a file, a Python file that I can run anytime I want to. But I'm utilizing this for being able to then trigger the action to pull the container down, or actually initiate the container, and then make the call to Giphy.com to then be able to do its job and put it on the web page. So, without further ado, I have this absolutely amazing website that I've created here, and I had to put the long title on here because I was allowed to, because this is my website, right? But all it does is makes a call out to the Salt Master, gets some GIFs, and based off of this specific keyword, whatever it may be. So I'm going to pop over to my master here for just a second, and at the bottom I have the event bus running. So I'll just say salt test.ping, make sure it's alive, and it is. Does that look okay? Are you guys able to see the code all right? All right, excellent. So essentially, when I select one of these, or when I click one of these, it's going to pop a GIF out. So I'll just say get a Giphy. And you'll notice that it runs it triggers the action in the side, or it dumps it to the event bus here, all right? So because I have to, there you go. Really, really like it. I'll do it again, so we'll get another GIF. And if I scroll down, another one's pulling through. Yeah, pretty amazing, right? All right, hang on, let's get another one. All right, so
Oop, I get my next one, and it'll start peeling through here. Oh, yeah. Oh, yeah. Here we go. This is on a T2 Micro in Amazon, so there's not much RAM in this box, but it gets the job done, right? And of course, the originator of the salted things, right? Okay, so effectively, looking at the event bus here, you can see that every time I ran or clicked on that button, it basically was just making a call out to Giphy and utilizing that exact set of details that I mentioned previously. So it specifies that Python is the language that I'm utilizing, and it specifies that I'm using the Python file of giphygit.py. Now, the purpose of this really is just to show that from a functional standpoint, there's really nothing magical about what's being done in today's infrastructure unless you build the magic. And Salt provides you the ability to build that magic by doing something really quite simple and specifying a single action or a single usage for that specific case that you're looking to do. So, again, the engine side of things, let me pop over to this code here. Looking at my code build, no, not my code builder, my HTTP. This is, again, just that engine, and this engine is running over and over again, just checking to see if there's any updates to my event that I'm trying to do here. And all it does is make sure that the web server is running, right, as I was showing. But then it just fires to the event bus the details of what it was that it ran or was attempting to run. So now taking this a step further, utilizing a built-in engine within Salt. Let's go into I have, without having to type anything at all, I added the Docker events engine, which if you go to our web page and, oh yeah, there you go. That's a good one. All right. Reset that. You go to our web page, we have quite a few engines, as I mentioned previously. But these engines are able to be utilized just by simply applying it to the master configuration. And really, the detail here is, in this case, it's just looking for a specific event to happen, and we're looking at the API, the Docker API, in order to be able to validate when it's doing something. So I'm going to go ahead and restart my master, because I just saved this. You guys have any questions so far? I know I've kind of ripped through a whole bunch of stuff. So I have not uploaded it yet, but it will be before the end of the day. Hecklers. Yes, no. I'm sorry, say that again? So thank you for noticing. It has absolutely nothing to do with anything except for the fact that, can anyone tell me what they are? All the different forms of salt. And I do have at the very, very end, because I love you guys, that table. All right. So I'm gonna kick off this Giphy again, make sure everything's up and running, and fire off a GIF. And there it comes. Now, the difference now is I added the Docker engine events. And so now I can see the sections for where we triggered off of the event bus, but also all of the actions that happened once it gets to here. All right. So this is the old ones. This is what I was doing previously with my engine, which was just dumping the detail to the event bus. But then utilizing the Salt engine, or the Docker engine, it shows you a ton of information. The ID of that specific container, what type it was, where it came from, as well as the status. And so in this case, obviously, working with the Salt events are very easy. For those of you that are not familiar with the event system, this is going to be your lifeblood in everything that you do within your infrastructure for being able to make reactions and behaviors change with whatever is going on and responding to the events of your infrastructure. So in this case, I see the event of Salt Engine's Docker events create, and then my event comes into attaching. So I attach from providing the name focus bows, as well as then the connect and the bridge function for it, and then the start event. So I could have triggered an action off of any of these events to do something else as well. But then it even goes down to the die, kill that container, right? Not really overly complicated, but it's just the ability to see some details. And then you can take this content and every one of all of the information that's replied or returned back, you have the ability to action off of. Of course, I tap the word action. That has nothing to do with the actioning function of what we're talking about here. It's just simply what the action was for that particular container. And then lastly, we have the disconnect. But it does this all very quickly, feeds the GIF back to the UI here, which was really nothing more than, where's my actual code? Right here. This is I really am not a web developer, so maybe by next year I'll have some time to learn some things and add a little file called something.css to make this a little prettier. But effectively, this is the way that it looks now. And then the Giphy.js, this is just some JavaScript that does the actioning portion. So specify the text field value and then return that or run that through the function of append image. And then we just specify that it's a marquee image detail so that it goes sliding across, because I'm really not very amazing at web development. So again, this will be something that will be updated hopefully by next year. But all it's doing is specifying the serverless API, and it's really the local host that's running this. And then it pulls back the URL and returns that detail. And then, of course, clicking the reset. One more thing to show. If I do Docker ps, nope, Docker ps-a, I can't type. So this is every one that has happened. As you can see, I started working on this about 2 weeks ago, and then played with it again 10 days ago, 7 days ago, 4, 3. Notice we get closer to the conference, and I start losing my mind. Does it still work? Does it still work? And then about an hour ago, while I was waiting to do this, and it still worked, so I was happy. And then just now. But utilizing the Salt event bus, being able to see all these things and make actions and responses to what you have in your infrastructure is quite powerful. Now, while this is a really silly example, the purpose to this that I really wanted to get across to you guys is that functionally, we all chase squirrels. Now, functionally, you have the ability to create a solution that is essentially a component of whatever it is that you need to do. So from a conclusions standpoint, I guess, this went a little faster than I expected, so I should be able to spread it out a bit more. But so serverless really is a pattern overall, and what's happening in function as a service, if you will, is really it's not provider-based, which some organizations will tell you that it is. It's not. You have the ability right now with the power of Salt to be able to create components within your infrastructure that are fed back to your infrastructure or your organization. So the first thing that pops into my head is, wow, we can actually really make the IT department a business unit that has the ability to have their customers purchase these services. You can create a user type of service, creating users that does functions. You could utilize it for implementing infrastructure very easily. Salt being easy to utilize to be able to create those configurations quite simply. If one of your users says, hey, I need these specific specifications for this particular test that I'm doing, you don't even have to touch it. You should be able to have Salt allow you to create a component to be able to do this exact type of scenario. So moving up the stack, really, this is where I'm stating that using an automation framework for just configuration management is really missing a lot of the picture of where you can go with this solution. Salt is a remote execution framework, I like to say, on steroids, but it doesn't give you any of the jitters or roid rage. And I say that joke all the time, and no one laughs. And my wife has told me over and over, stop using that joke. It's just not funny. But I do it every time. So maybe one of my friends could laugh heavily for me. Thank you, Seth. Thank you, Seth. And basically at the end of this, automation is more about just configuring the system state. It's about doing other things. And because we have these features of containers and the ability to use different solutions such as a microservice to do a specific task, really where you go with this is unlimited, except by your own imagination. So do you guys have any other questions or any questions at all for what I've shown here? Dead silence. That's either really good or really bad. It's one or the other, right? Yes, sir. That's a great question, and to be fair, the humorous part about me doing this talk is I don't really know Docker very well. I was going to point to my Docker buddy over here, and I'm not a web developer, but I know Salt, so and I know that you can do a whole bunch of stuff with a whole bunch of different technologies. Yes, sir? Say that one more time. Yes, so perfect. So utilizing the Docker events when or either die or disconnect, right? Probably disconnect, right? If you watch or have a reactor looking for this specific event, then then you can do something else, right? So if you guys are, let me see, I think I have my, let's go back into here. No, that's all I have in there, that's right. So if you wanted to add a reactor to your master config and just looking for that specific detail right there, I could do it quite simply as, but I don't have any states that it's going to run off of, so. But effectively, you would put it right here. Do you have a question?
Oh, just going along, monitoring Docker containers. So if you have a Docker container that is running this time and something happens to it, will that just be pulled across that Docker event bus, the Sol event bus with the Docker engine?
So the question was if like just from any Docker container type scenario is what you're looking for? Yeah. So if any event that is Docker based, will it show up on the event bus? When I'm utilizing the Docker engine within Salt here, within the Reactor, my Reactor conf file here, utilizing the Docker events engine, it will. Every single event that happens will go across, as long as this is the host that's running that task. Exactly. Now, I have everything kind of all in one box here, so my master and my minion just basically doing the whole of its tasks. I didn't really need to spread it out. But from a functional standpoint, since we're talking about serverless and microservices and all those sorts of things, I could have easily had a single master sitting somewhere and multiple hosts out in the world somewhere to be able to do their jobs. And then anytime, in fact, our presentation for next year, I suspect I'll be making it a bit more robust with being able to do a whole bunch of other things, such as orchestrating additional load, when load is happening and so on and so forth, and provision more infrastructure, so on and so forth. Yes, sir? It would be, it's going to be on, so my Git ID is Salty Charles, and it's going to be github.com, Salty Charles, SaltConf17, I think is what I'll call it. And it's going to be open, so if you guys contribute to it to make it better, that'd be really awesome, because mine is quite boring. Any other questions? Yes, sir? I knew someone was going to ask that question. Okay, so let me go over here. So the question was, I used a command run. Isn't there or aren't there Docker modules within Salt? And the answer is yes. So we have 8 different pieces here. Now, Docker mod is the new version, or has been updated since, or has changed in 2017.7. And effectively, I could have used this, but doing the quick and dirty to also state that it doesn't have to be a function that is built by Salt already, or a module that's built by Salt already. You can still make calls to other things. So it can be anything was really the purpose to me doing that. So but the answer is yes. There are Salt modules, and I could have dumped them into here and utilized them for each of the different tasks that I was running through. But to keep it as flexible as possible, I utilized the command run. Great question. Didn't want anyone to ask it. Just kidding. Yeah, it was fantastic. Any other questions? So, let me tell you a little story. A couple of days ago, I was sitting in a room with my cohort Cody here and Tom and one of our customers, and he was doing a presentation for his management about a reactor that we set up, or some orchestration events that we set up. I apologize. The question was, how much do you think, or how well do you think the event bus will stand up to lots of events? The short answer is incredibly. The long answer is this long story that I'm going into right here. So the process was basically that we needed to validate an auto-scale event and trigger an action on a third-party system, and then based off of behaviors, do some other things, depending on if the node is failing or something, maybe spin it down and deregister it from that third-party system. Well, what we didn't know was there was another part of the organization that was doing a demonstration, a totally separate demonstration on AWS, and that's where everything was, obviously doing the AWS auto-scaling functions. And the demo was to spin up 10,000 nodes. Well, we're sitting there, and the demo we wanted to show to his management, we couldn't show because the event bus was screaming. But it was sitting there, taking the events, doing the grain data update that it needed to, pulling systems out of the pool as needed, putting them right back in as needed. It was absolutely flawless. And we're sitting there, myself and Cody and Tom, we're sitting there watching the event bus like we're watching fire. It's like, oh, that is so awesome. And then I turned and looked at both of them, and they're both like, oh, that's so cool. Yeah, we're geeks, I know. but effectively, this is one of the most robust systems that has ever been written. I would challenge you guys to break it, because we want to make it better. Now, don't be wildly nefarious. Let's break it in a way to make it faster. We have found some hiccups, and I think there could, if you talk to some of the other engineers in the back, they would be able to tell you a little bit deeper what which pieces are a little slower, or where we think some efficiencies could be made. But those guys in the back over there are constantly making updates to the code, so to keep this stuff running. Any other questions? All right. Thank you.